So our speaker today is Dr. Ebenezer Mieza-Kwofi. He joins us from the University of Arkansas, where he's an assistant professor of food systems, sustainability, and resilience. He has a joint appointment in the Biological and Agriculture Engineering Department, Chemical Engineering Department, and Food Science. Prior to this position, he was a research associate and manager for International Food Systems Development at McGill University. His research explores the connectivity and dynamics of environmental, economic, and product process efficiency to address food system sustainability and resilience. Please join me and Dr. Kwofi as we kind of embark on this conversation. And his talk today is entitled "When Circularity Becomes Central to Our Global Food Security Agenda." Exploring concepts to implementation readiness in the rice value chain. Dr. Kwofi.
Thank you. So I'm going to share my screen. Do you see my screen?
We do, but again, it's showing the opposite one. So,
okay.
There we go. Perfect. Thank you.
All right. Thank you. And thanks for the introduction. So I welcome all of you to this presentation titled "When Secularity Becomes Central to Our Global Food Security Agenda." And what we will be looking at would be the global food security agenda, what is missing within that agenda, and how we can weave secularity into this global food security agenda. And I would be drawing some examples of what have been done within the rice value chain. I used to work on international food system development. So part of the work that we did is what I want to talk about, but also to draw some input out of that and to see how we can mainstream secularity as we work towards global food security. So I will begin with what have become more of a consensus to all those working within the food system, which is our food system is failing, and it's failing in these four dimensions: its inability to feed the future population, its inability to produce equitable benefit for all, its inability to deliver healthy diet, and also the unsustainability of the system and how it impacts the environment. And would agree that this impact also affects food security, social justice, nutritional security, and also the natural resources. There have been evidence across board from an environmental point of view that the implications of the current system is enormous, and that if no technological changes and also dedicated measures are put in place, then we could have this environmental effect of the way we operate now to increase by 50 to 90%. And if you look at this this publication that was published in Nature in 2018, you could see that across all the different categories, whether it's greenhouse emission or cropland use or nitrogen or phosphorus, they seem to be at least a 50% more impact if we keep things as they are now. But also from the food waste perspective, since we already know that at least about a third of the global food does not reach consumers. Now, from a food security point of view, that is about 1.3 billion tons of food that get wasted. And that amount, it's 4 times what is actually necessary to feed the people who suffer from hunger today. From economic point of view, that amount of food that is wasted represent about 2.6 trillion in terms of cost to the environment and also to the society. Now, from the environmental point of view, the implication of the food waste is that we have a lot of water which is being wasted. And in this case, it's equivalent to satisfied domestic consumption of cities like New York for 120 years. That's a lot of water. But that also takes away farmland that could be used to produce food for consumption. So we have roughly about 30% of agricultural land worldwide that goes for the production of this wasted food. And obviously there is some greenhouse emission, in this case about 3.3 billion tons of emission. So what has been the global response to this threat? Because we all know it. And as we are aware, in 2015, the Sustainable Development Goals came into effect to replace the MDGs that started 15 years earlier. And within the 17 goals that were set up, the goal number 2, which was to end hunger, but also to achieve food security and improve nutrition, as well as promoting sustainable agriculture. Now, this shows that the agenda number 2, or the goal number 2, is central to a lot of the other goals. And so the food that we produce, if we target ending hunger, then we would have to fix that within all the other 17. But this is also rely on the basis. If you look at this Sustainable Development Wedding Cake that was developed by the Stockholm Resilience Center, you could see that the base of this global agenda would be the soil, okay, the biosphere dimension, which becomes necessary to support any social and economic plan. And different countries have contributed towards this global food security agenda. In the US, for example, we have the Global Food Security Strategy, which was set up as an act in 2016 and running from 2017 to 2021. So different countries have supported this global food security agenda. Now, the problem at this point is that there are evidence that we are not on track towards this zero hunger. And so we might have to change direction. And in the next few slides, I want to highlight some of the evidence that requires our immediate attention. So the SDGs were set up in 2015. Then in 2016, the people suffering from food insecurity, acute food insecurity, was accounted as 108 million people within 48 countries. Now, if you look at 2017, the number of countries went up to 51, and the number of people increased to 124 million. In 2018, the number of countries increased to 53, although the number of people went down to 113. But by 2019, the number of countries had gone to 55, and the number of people 135. Now, this picture has one message, that we are not working towards zero hunger. because the numbers keep increasing, the number of countries keep increasing. And if you look at the distribution, you would see 73 million of these people are in Africa and about 43 million in the Middle East and Asia. Then in 2019, we got COVID. And COVID disrupted the food supply chain. And it came with significant implications for global food security. It only did not affect the production, but it affected the whole supply chain, consumption, production, distribution, and the impact was enormous. If you look at the report that the Global Food Security Program brought out at the late 2020, you could tell that the COVID actually almost doubled this number of people facing acute food insecurity from 135 to 265 million people. And so if you follow all these numbers since the SDG came into effect from 2015 to now, certainly we are going upwards in terms of food insecurity. And that would require a change in direction. Now, the ZeroHungerChallenge.org came up with this specific challenge that need to be addressed in with regards to sustainability, that we need to change and become more sustainable from production to consumption. But then they also highlighted the fact that we need to double small-scale producer income and productivity. Then there was the issue of the food waste and food laws, which is increasing but needs to change. Then with regards to health, a healthy diet. Now, the point here is that sustainable food are not necessarily healthy, or healthy food are not necessarily sustainable. And so this will require a conscious effort to ensure that we are bridging sustainability and healthy food at the same time, not one at the expense of the other. And so if you put all of these together, it makes circularity very critical to this. And over the last couple of months and a year and more, ASAB has been spearheading food system circularity. And this is so critical because it has it kind of creates the opportunity for us not only to deal with waste or out of the food system, but also to ensure that we weave this circularity plan, this circularity agenda into the bigger food security strategy, because this is essential. Now, we have understood over the last couple of seminars that circular food economy would mean that we would have to design out waste and pollution. We have to keep a product and material in use, and also ensure regenerating natural system. And we thank the ASAB leadership for spearheading this. I think that there have been a couple of activities, and this seminar series, for example, is one of them to help talk more and discuss more about circular food economy. But the point I want to make here is that that plan, that agenda, would have to be integrated into a much broader food security plan. And so that if we're able to do so, then we are solving not only the environmental problem, but we are also using the waste, or we are redirecting the waste to ensure that people have food to eat and have more nutritious food access. And so in the next few slides, what I want to do is to talk about some of the strategies that have been applied in implementing circularity with a view of enhancing food security. And as was mentioned earlier, over the last 5 years, I've been working in developing countries working with small-scale farmers and communities. And part of that is what I want to share today, and extract some information that might be necessary for rice value chain circularity, and also highlight some of the work that other people in my department are also doing. So let me begin with the rice value chain. So the rice value chain, as we all know, has input, production, collection, process, wholesale, and retail. And then also there is also consumption. But within this linear system, there are outputs, which would include the straw, the green grain and stained grain. We have husk, we have broken rice, we have germ, we have bran. And so for us to circularize this, that means that we would have to find a way of redirecting the waste back into the linear system. And that way, we will be working towards circularity. And so the opportunities within the rice value chain can be enormous. However, they would have to be examined to see their feasibility, and also to demonstrate whether they make economic sense, or they make more technical sense, as to choose one option over the other. And so on this slide, what I'm showing is that for us to circularize that linear system that we saw earlier, we may then have to redirect some of the input, some of the output which are considered as waste, back into the system, the linear system. And doing so, we also have to bear in mind, how does that go into a food security agenda? And in this case, we're looking at availability of food, we're looking at utilization. And so I would now want to showcase what has been done within a low resource setting community, and how that idea of circularity was pushed into a food security plan. All right, so within the community where we attempted implementing circularity at a local level, the key issues were that they were producing rice, parboiled rice, and they would have to gather wood, or they would have to buy wood that are brought into the community, and they would have to process the rice using 3-stone stove. But then they also had rice husk, which they would have to set ablaze, burn, with all the emissions and all the issues that had with it. Now, the implication of that was cutting a lot of wood means that there is deforestation, there was greenhouse gas emission as you burn all the rice husk, there was destruction of biodiversity, but then there was also the health impact, because there were issues of itching and burning eyes, there were issues of throat irritation, bronchitis, the aggravated lungs, and also conditions like asthma. And so all of these put together mean that solving one problem might be good, but might not be very effective in looking at the much broader food security plan. And the plan would be that people will have access to food, that there would be more available local rice for local consumption and also for export, that people would make enough income from the work they do. And so what we did within the community was to examine what were the main impact categories, and how the category affected the productivity of the people. And so, for example, the current the parboiling system that they had led to low quality rice, and also reduced the competitiveness of the rice they were producing. Now, the cost of fuel was about 12% of the total cost of processing. But that would also mean that if we could find a way of reducing that cost, then that would enhance productivity. But then the other one was that they spend a lot of time collecting wood for the processing, and the open burning of the rice husk caused pollution and also sickness. So we looked at three interventions. One was to enhance the parboiling technology, and two was to find the best way to use the rice husk as fuel in place of the wood, and then also to aggregate the processing unit, because what we saw was that if they operated the way they were, then the capacity was much low. But if they aggregated the whole system, then they would have much benefit. And if we are successful with this, then we would enhance energy supply reliability, we would enhance the competitiveness of the rice, and then also there will be a clean environment and higher income for the farmers. And so this was the plan that we had, that if we can tackle this way, we might be solving multiple problems with the same solution. And part of what we did was to examine the rice husk, and we looked at different options. Direct combustion, we look at briquetting, we look at gasification, we examine how much of the wood can be replaced, we looked at the environmental implication of that, we look at cost. And if you put all of this together, we settled with the direct combustion and gasification system for the local community. And so at the end of the day, these were the benefits that we got. We were able to reduce the total energy used by half by the system that was developed. We were able to minimize that open air combustion significantly within the community. We were also looked at the cost. So the cost of processing came down significantly. And also, although we didn't measure the impact on health, but considering the fact that there were less to no emission of smoke from the combustion of the rice husk, we could conclude that there were some health impact gains with the system. Now, if you look at all of these from a food security point of view, it means that now rice quality is improved. We have less, they have more time to do other things rather than to go collect wood. We improve the economics and also improve the environment. If you look at the system that was developed, comparison of that system to what they used to do, you could see on the graph on the right that this is from a life cycle analysis of the system that we developed, that there was significant difference between what they used to do and this new system. So overall, the point here is that when Secularity using Secularity, which is targeting the use of the waste and to feed it back into the system, when we target that, we are able to significantly improve different components, which in effect enhances the food security and have more access, people have more access and to food than they used to. Now, the other thing that I also want to highlight, so apart from, in our case, we were using the rice husk for heat generation, but other people have tried different approach of Secularity to enhance food security. And one of them was this paper that was published in 2014 that was looking at rice husk for energy, for power generation. And here they looked at they built a scenario based on what some of the systems that were happening at the time. And from this table, you could see that depending on the capacity, there was enough power generated to support the mill for the mill consumption, but there was also excess electricity that could feed a number of customers, a number of households. And so, although this is not seen directly as food security input, but if you look at it more broadly, if people have energy that they do not have previously, then there is the opportunity for them to do other things that would enhance their livelihood. There is also the energy that goes back into the rice milling. And so here again, it's still the idea of circularity, using the waste to produce something that goes back into the system. And this is what the rice value chain circularity could look at. Now, the third thing that I also want to mention, which is part of the work that one of the colleagues on campus, Dr. Ben Rankel, is leading in another project. And they are looking at production. So returning the waste not into energy generation, but also into soil amendment or on-farm amendment. And with this plan, there are a couple of benefits that could be highlighted. There is the opportunity to minimize climate impact on rice production overall. There is the opportunity to reduce irrigation, water use. There is the opportunity to limit toxic metals accumulation in the rice. There is also the opportunity to improve nutrient use efficiency. Then there is the opportunity to use also the waste that is generated, in this case, is the rice husk. But also, it would help to close the silicon cycle within the paddy environment. So right away, we see that there are options or pathways for circularity, either energy or non-energy alternatives. But it comes with a couple of challenges. Now, if you take the energy options, for example, the reliability of the rice mills is a critical challenge, because if you're relying on rice husk to produce energy that people use for other things, then when there is a breakdown within the supply of rice husk, then that whole energy production system becomes handicapped. The other one would be the transportation cost, which means that we would have to, if we have our system set up much further away from where the rice are milled, then the transportation cost gets in the way, because it would reduce the overall benefit from it. But the other thing is the investment cost, okay? The investment required, for example, a 200 kilowatt system can easily reach about $250,000 US. Now, that is a substantial investment for rural location investment. And so for the companies and the people who want to get involved, they would have to master adequate financial resources in order to do this. But also, they also have to master some relevant experience to have this running. With regard to the soil amendment, for example, we need to understand what the agronomical consequences would be. Are there environmental implications? Are there what are the system needs? Are we able to track, for example, okay, if we do that, are we able to track the quality through consumption? Do we know the cost implication of all of that? So those things would be some of the critical challenges that may need to be addressed in order to mainstream circularity within the rice value chain. Now, there are other pathways. For example, the bran could be used to produce oil or get other bioactive components from them. But all of these would have to be viewed and examined from a technical and economic feasibility. Are they scalable? What would be the critical issues to address when we want to consider their scalability for on a large scale? So with all of these, we have one conclusion, and I have one concluding thought before I wrap up on my presentation. And that thought is this, that there is an opportunity to integrate or to weave circularity into food security. But that plan, that agenda would require collective effort. It would require a system level approach, because we see that the problems are multifaceted. And so looking at it one-sidedly does not provide a holistic resource and would have impact on the other component. Besides, when we realize or we recognize that we would have to work with, for example, the economics would have to work with the process engineer would have to work with the nutritionist in developing a much more comprehensive plan that has at the core food security as an aim, but also has circularity at the core to it. Because if we're able to achieve that, then we're sure that we're not only protecting the environment, but we are providing food for everybody. And the final thing that I also want to mention is that this plan of circularity has actually been around for some time. In other fields, maybe more work has been done, not so much with food. And so we do not have to stop at a technical point. It would require policy, it would require investment. And so those that have the capacity to support these this plan, this agenda, would have to also have the necessary tools in terms of what policies would ensure that, because if the policies that are in place are such that they don't promote these kind of integration, then we might not be successful overall. And so I would stop here and thank the organizers for the invitation, and also for the opportunity to present some of the things that we have done, and also to bring up the discussion of us looking at circularity more broadly from a food security point of view. Thank you.
Thank you, Dr. Kofi. We've got one question that came through the chat, and then I've got some other questions that came up in my brain as well while you were presenting. The question from the chat was, and by the way, anybody else, feel free to throw your questions on the chat and I'll relay them, or Ebenezer, you can monitor that as well. But so the question is, do GMOs or GMO advances play into your plan for improving food security? And what does that look like from your perspective?
Okay, thank you. Right, so the issue of GMO has been a very big topic, not only here, but also in developing countries. there has been a number of misconceptions around it. And so if you look at the local understanding of GMO, then there would be a pushback at that level, because I think that part of the communication of GMO maybe has not been done effectively. And so you would have that kind of pushback. But overall, if it enhances how much food will be available, if it enhances people's accessibility to food, if it enhances our overall plan towards mitigating environmental impact, then of course it would enhance food security. But if there is if these three things are not fully achieved, if it does not enhance how much people have, then definitely it would not be in the best interest of food security.
Okay. Thank you. We've got another few more that came in, so thank you for those that are submitting these. First is, when you improve the circularity of one aspect of the system, carbon or energy, for example, in a rice system, what other measures of circularity do you believe should be evaluated? And specifically mentioned nitrogen, phosphorus, water, et cetera.
Okay, so depending on, I mean, within the rice value chain, depending on which pathway of circularity you're following, for example, if you're looking at returning the rice husk, for example, to the soil, then a lot of the impact of that must be evaluated. Okay, how does that affect quality? Do we evaluate farm practices and their impact on quality throughout the system? Do we evaluate it at the processing level? Do we evaluate it at the consumption level? Or we are only interested in how much produce we're able to get, or we are only measuring the impact on the environment? Because some of these things go beyond the environment. It also affects other things. So yes, I agree that the evaluation must be much broader. It must look at the soil implication. It must look at the quality implication. It must look at the cost implication. That way we have a more holistic understanding of these pathways. And I think that so far, for most of the pathways that are possible, not much has been done in terms of quantifying these different dimensions. And so as we discussed, this will require that more of the research goes into understanding this at a multi-level, not only at one side.
Thank you. Another question. I like the idea of a local circular systems to promote local self-sufficiency. What do you think the biggest hurdle is to implement this? Is it, for example, technological, cultural, government? What keeps us from doing that?
Okay, so I think this has multiple phases. Okay, because yes, culture is critical. Now, you would agree that there have been several interventions that almost die immediately the money is finished. Okay, and so in this kind of intervention, to ensure continuity, at least in my experience, there has to be ownership. If the people that we do this for, if they don't feel that they own the system, if they don't feel integrated, if they don't feel part of the solution, then we would continue to have the kind of result that we have, that as soon as people come, I mean, the first question they ask is, what is in it for me? And what is in it for you? Okay. And so that approach that have been used in the past has not been very successful, because I mean, think of it. there are a couple of interventions that were planned even before the people got to the place. And so you get there to realize that there are other issues that need to be addressed in order to make your intervention more successful. Number two, most of these interventions are almost cast in stone, and there's no flexibility to address the critical issues. And so that model ought to be revised. Now, the third thing is that in our case, we had different things that were running at the same time. We were looking at the technology to improve the quality, but we were also looking at the rice house utilization. And part of the problem that we encountered, because when we did the economic evaluation, we looked at different scenarios. What if the government was sponsoring part of this within the community? We looked at what if the banks were supporting this at the in a 1/3 in a 1-to-3 ratio. So we looked at several scenarios, and the most effective scenarios was to have the community, the government, and also some agencies to support, because we realized that if there's no commitment from the community, then that's not going to work. So there has to be that commitment from everybody in order to have this running. So I think that I would stop here.
Yeah, that's really interesting. I think a lot of us can identify with that, right? If it's not our idea, then it's not necessarily always a good idea. It's a lot easier to get on board with that if we can keep it as part of our culture. So there's another question. I think this kind of relates to the last one. It may be already answered. This individual says, I haven't worked in Africa for some time. In what ways can the concept of circularity be promoted for use by those smallholder farmers within the sub-region?
Okay. Yeah, I think that this question is a very important question. And I like the fact that ASAB is actually leading this modernization of Africa program. And I think that we would, as we talk about circularity, we would have to weave that into this whole the AMAA plan, because it would significantly enhance the program. Now, I think that during the ACB meeting, a lot of things were discussed, but the critical ones that were discussed, one could include land, include capacity building at the local level. And when I say capacity building at local level, I would give one example. We did some work in Malawi, and over there we realized that there were sunflower seeds that were being sold so cheaply, but a single press, okay, could convert that sunflower seeds into oil. And so while we were there, of course, it was not part of our plan, but then we encouraged the young people who were involved. And 2 years after the project, we now have 2 of these young people who are running a full sunflower oil business within the community. And so we think that when we are able to see how waste or several outputs from the different value chain can be fed back into the value chain itself, and we spearhead this at different level, we assure that we would make some success with all the things that we're doing. Now, the other thing also is that when we develop technologies outside this region, we have to make them adaptable to these regions, okay? Because we cannot just take technology and think that because they work here, they would work elsewhere. So that adaptability, it becomes critical, it becomes very necessary if we want to go far with this, especially international development towards food security.
think you might have almost indirectly answered one of my questions. So thank you for that response. Um, so let's see. The next question: do you think upcoming and quotes around relatively new mega trends such as plant-based protein have a greater opportunity to implement circular food systems compared to some more long-standing legacy agriculture?
Okay. Right. So that's I think that debate is still ongoing with the plant-based protein. That discussion is still ongoing. But there was this publication that was published that recently that if we kind of script all the animal-based protein, we might not necessarily have that significant emission reduction as we intend. Now, what this means is that there would have to be a conscious effort to have the plant-based and animal-based alongside, but with an improved efficiency in terms of water use, in terms of energy use, and all of that. That is critical. Now, not so much about plant-based in the areas that we have worked. Not a lot of that discussion is not there, because in some of these places, the cost of animal protein is so high, so they basically rely on plant-based on plant protein rather than eggs and meat and chicken. And there are several interventions that are looking to promote local rearing of animals to enhance the protein of these communities. But as it stands now, not so much of that discussion, because primarily because of cost. They're more expensive than the plant-based that, I mean, they grow by themselves.
Okay. The next question is, what about the other parts of the rice? So you showed the chain, and I think you you addressed the husk, right? But what about, for example, the rice straw? Can it be used, or is anybody doing any work in that area to understand how that can be part of the circular approach?
Okay, right. So there are a number of different works that have been done. Now, the challenge has been that we have not successfully examined the scalability of these systems. And like with all waste, if it doesn't make economic sense, then nobody wants to do it. And so it would require that like, for example, if you take brand, there's a lot of work that has been done on brand, but we don't know the scalability of that. What will it cost? What kind of investment do we need to do that? Is it profitable at this point? So those dynamics are still not clearly known, and so they are not actually in operation. It's still at a lab level. So I think that's what would require us that have met here to look at some of the opportunities there are, and to come up with some of these technical, environmental, economic feasibility of scaling them up.
Thank you. I think one of the last, if not the last question, and it's about timing is really good here, is the food supply chain is quite global, where wheat, for example, wheat produced in Australia is processed in another country to produce flour and then consumed at a McDonald's in Thailand. There are waste streams at each of these these locations, and often it involves a group of other companies through the entire process. So what is your view on taking what you've learned at more of what might be called a local level and applying that to that global supply chain?
Okay, so you know, we need to realize that with regards to capacity, these local areas have way less capacity in terms of the production. Now, for them to be able to feed more into the whole global chain, we need to enhance capacity. I mean, in the US, farmers get subsidies, there's a lot of support. Those kind of support does not exist in these local areas. And so to expect that they will be able to produce at a competitive level, that would just not work, right? And so there has to be a conscious effort to enhance capacity and enable aggregation of these smaller units, because that is the only way the economics of scale would make sense. Other than that, if they still do the tiny level, then it doesn't work very well. And so for us to have more integrated system that allows small scale production to increase, there would have to be that effort from all different stakeholders, from government, from international agencies, in order to make this more achievable. Other than that, if we leave things the way they are, then within the next 20, 30 years, we will still be providing aid, but it would not solve the problem.
Thank you. Well, we're kind of approaching the end here, and I think that was the last question we've had in the chat window. Kind of like to take a few minutes here and wrap things up. First of all, thank you very much, Dr. Quofi. Was very educational, especially for a Midwestern. Grew up here, spent a lot of time in the Midwest of the U.S. and relatively sheltered relative to the rest of the world and agriculture there. And it's really interesting to see some of the results that you've shown. So really appreciate your time. And thanks to everybody else who called in today. And thanks to Jasper, who's helped out immensely with this member hour effort, and several others that helped to make this one particular one a reality. So this is the second installment of a 5-part series of these member hours on the circular systems. So our third installment is going to be Thursday, October 14th at noon Eastern time. And Dr. Joe Sagas will be discussing coupling circularity with carbon negativity. And let's see, I think Jasper, I'll drop the link for the registration for that will be dropped into the chat directly here. Give me a minute. There it is. So you can go there to register for the next event that we have coming up. As well, Jasper will be sending out after this meeting a link to a recording of this, so you can feel free to rewatch again and share. And I'm sure Ebenezer would not turn down if somebody wanted to reach out to him as well. So thanks again to everybody for calling in, and really appreciate the time today. So.
Thank you.